We start by creating left and right copy logical modules, since we will need them in more than one pins. These signal if we are moving left or right. Next, we add some if-double modules, which will add a certain amount to the x-coordinate, negative for left direction and positive for right. We export those pins from the group, since we need to change them from outside. They are like function arguments. Next step is to make the double value a vector. For that reason, we multiply with the unit x vector and then add the value to the b pin of the addX node. We will use the b pin node to accumulate the vector displacement for the x direction. The accumulation is done with the hold module. First, we need a signal that we should let the new value pass. We do that when we move left or right. We connect it to the passIf pin and the out pin from the addX node to the in pin of the hold module. All we need now is a set vector pin to update the b pin of the addX module. We finally just added a reset logical pin. If it's true, we send the 0 3D vector to the hold module, which sends the camera back to the original position. All we have to do now is create the same group for x, y, and z directions. Finally, we create the same for the rotation along the y-axis, but this outputs just a number, the angle of rotation. We now export all those values to a control board so we can easily tweak them. The next step is to create the final transformation. We add the x and y transformations and the result to the z transformation. We can successfully calculate the new position. From the angle of the rotate xy group, we create a rotation y, and we just provide the angle of the rotation. This will generate the transform we need, but we need to get only the rotation part of that transformation. We decompose it and get just the rotation part. Now we put it all together with a compose transformation node. We have the position and rotation components, so we provide them to the corresponding pins, and we are done. This is the new delta transformation. We get the before transformation and use a concat transformation node to add to that our delta transform. The only thing left is to make that a smooth experience. So we add in front of it a smooth transformation node and provide a delay, so it will transmission smoothly. The delay is given from the control board. We actually have two values, one when transitioning between left, right, etc., and one when we go back to the initial position, which is much faster. Now we just need to add the camera joystick to our project. We right-click on the Virtual Cam module and select Edit in Place. We press Ctrl F and search for Switch Transformation. We will put the camera's joystick transformation in the middle of this connection. This is straightforward. We create a Transmit Transformation module and put in the Into Tunnel pen a name. Here I selected Final Before Joy, but any name is fine. This is we need to feed that to the camera's joystick as a before transformation. We add another Transmit Transformation module, and this time we select the previous name from the From Tunnel dropdown. We connect it to the before pin, and now we need to forward the new transformation back to the compound. Create another Transmit Transformation module, and this time we add another name in the Into Tunnel pin. I named it Final After Joy. There is one last step now. Get that transformation and put it in the Switch Free Transformation module. Create another Transmit Transformation module, and this time we select from the From Tunnel dropdown the Final After Joy tunnel. We now connect it to the second value of the Switch Free transform, and everything should work now. When we activate the joystick, we should be able to move the camera, And when we deactivate it, we should be able to go to the initial position.